right, lesson 6.6. So we have spent quite a long time on factoring, and we're really not done with factoring just yet. But what we're going to do today in this lesson is solving polynomials by factoring. And when we solve a polynomial, essentially what we're doing is finding the x-intercepts. And so just like we did with quadratics, we will factor first and set each factor equal to 0. And so you'll have to take those factors and then solve those down. For some of those, it'll be really easy. There will be some that you will have to use the quadratic formula for. So let's look at number 1. And this is just a mix of all the factoring types. So you have to look for GCF. You need to look to see how many terms it is, all of that to determine how you're going to factor it. And it needs to be factored down completely. And also, if it's not set equal to 0, you've got to move everything to one side first. So kind of a lot of things to remember on these. So number 1, is it set equal to 0? Yes. Does it have a GCF? Yes, it has x. So if we factor out an x, we get x squared plus 1. Does this one factor down again? No. You might think, well, those are both perfect squares, and they are both perfect squares, but there's a plus sign, and we do not have sum of squares. So once it's factored completely, you take each factor, so x equals 0, and that one, that's all you have. You don't have to do anything. So it has an x-intercept at 0. And then you take the other one, x squared plus 1 equals 0. Since I don't have a plain x here in the middle, I can just subtract 1 from both sides and then take the square root. So if we subtract 1, we get x squared equals negative 1. And to get x by itself, I take the square root of both sides. What do you remember about the square root of negative 1? It's I. So x equals, just like we did before, we have plus or minus I. If I were to type in x cubed plus x, I'm really only going to see it cross the x-axis one time. Over here, when it has an I, that means we say that it crosses at an imaginary spot. So it really doesn't cross at all here. So we have one true x-intercept. All right, number 2. Is it set equal to 0? No. So what do we need to do? Subtract 3x squared from both sides. And these are like terms, so I can just subtract those two, giving me 4x cubed minus 10x squared equals 0. Is there a GCF?
2.
2x squared, leaving me with 2x minus 5. Do either of these factors break down anymore? No. So then we take each factor and set it equal to 0. 2x squared equals 0. So if we divide by 2, what's 0 divided by 2? 0. X squared equals 0. And then if I take the square root, what's the square root of 0? 0. So x equals 0. Yep. And then this one, 2x minus 5 equals 0. If we add 5 to both sides, we get 2x equals 5. And dividing by 2 gives us x equals 5 halves. Just leave it as a fraction. Now this x right here had a 2 exponent, which means the multiplicity is 2. And remember way back, when the multiplicity is an even number, it's going to bounce at that x-intercept. So what should look like is it's going to sit on the x-axis and then actually cross at 2.5. Yep. Just like that. Number 3. Is this set equal to 0? Yep. How many terms do we have? 2. So it has to be either difference of squares or sum or difference of cubes. Which one is it? It's difference of squares. Now, 64 shows up on both the squares list and the cubes list. So why did you all say difference of squares? Right. The exponent here is a multiple of 2. So that's what makes it a perfect square.
So if it was like 6 or something.
So if this was x to the 6th, technically that would fit both of them. So if it was x to the 6th minus 64, you're going to have to do two things regardless. I would always start with the difference of squares because that's way easier. So I would do the difference of squares first and then break it down again if you can. So anyway, we have difference of squares. So what is your A? It's going to be the square root of x to the 4th, which is x squared. Remember, doing the square root, you divide by 2. That's why it has to be a multiple of 2. And your B is the square root of 64, which is what? 8. So this factors into x squared plus 8, x squared minus 8. Do we have difference of squares or sum and difference of cubes? No. 8 is a perfect cube, but the exponent with x is not a multiple of 3, so it's not a difference or sum of cubes, and 8's not a perfect square. So we cannot factor down anymore. So we're going to take each factor and set it equal to 0. X squared plus 8 equals 0. And if we subtract 8, we get x squared equals negative 8. And then we take the square root. Since 8 is not a perfect square, this is where we're going to have to break that apart like we did in Unit 5. What else is going on with this square root? It's negative. So we got to take out the -1, which leaves us with a +8. And what perfect square goes into 8? 4. 4 times 2. So we get x equals, we're going to have plus or minus. Anytime you're taking a square root, that's when you include the plus or minus. All right. Now, what is the square root of -1? I. What's the square root of 4? 2. And then the square root of 2 just comes down. And remember, you always want to put your whole number first, then your I, and then your square root. The other factor, we have x squared minus 8 equals 0. So you need to add 8 to both sides. And then you take the square root. The only difference in these two is that this one over here does not have the negative, so it's not going to have the I. And you don't even have to show breaking it down again because you really already did the work. Just don't include the I. So plus or minus 2 radical 2. Are there any questions on that? All right, number 4. It's set equal to 0. Is there a GCF? 5x. And we get x to the 4th minus what? 16. Does what's left in parentheses, does that factor down again? Yes. We had 16 is a perfect square, and 4x to the 4th is a perfect square. So what is my a? What's the square root of x to the 4th? X squared. And what is the square root of 16? 4. So we have x squared plus 4, x squared minus 4. Do any of those factor down? Which one? The x squared minus 4. We have a difference because it's subtraction, and both of those are perfect squares. Because, well, 4 is a perfect square, and then x squared is perfect because the exponent is a multiple of 2. So what's my a on this one? And what's my b? 2. X plus 2, x minus 2. If I set 5x equal to 0, and I divide by 5, what is x? 0. And then we have x squared plus 4. we subtract 4 from both sides, we get x squared equals negative 4. Then we take the square root. What's the square root of negative 4? 2i. Yep. Plus or minus 2i. Then we have x plus 2 equals 0. We'll need to subtract 2 from both sides. And that gives us x equals negative 2. And then we have x minus 2 equals 0. So we'll add 2. So this one has 3 x-intercepts that we'll actually see. The other 2 are imaginary. So if we were to look at this one, 5x to the 5th minus 80x, we should see it cross at 0, negative 2, and 2. And it does cross at all of those because there were no exponents outside of those parentheses. Like we didn't have any factor show up more than once. Number 5. Is it set equal to 0?
Yep.
Is there a GCF? No. So what method am I going to use for factoring? Sum of cubes. So basically your difference in sum, you do the same steps, but when you write your answer, one of your pluses and minuses are flipped. But it is the cubes. So we need to identify our a, b, a squared, ab, b squared. So what is my a? X. Your a is the cube root of your first term. And if you want to write that, the cubed root of x cubed is x. There's a 3 there. You can't see it. 3. And your b is the cube root of 125, which is 5. So what is your a squared? X squared. What is your ab? 5x. And your b squared? 25. If you didn't know how to get any of those, you might want to go back and check the part of the notes, the second part of 6.5, especially if you missed that day. And so then we're going to write out our factors. It's a sum of cubes, so the first sign that you have is a plus. Your first sign matches. X plus 5. And then we have x squared. Your second sign is the opposite, so it's going to be a minus 5x. And your last sign is always plus 25. Here's the thing about the cube. When you do sum or difference of cubes, this factor here on the right, you will always have to do quadratic formula with. These never factor down anymore. So let's go ahead and get the x plus 5 out of the way. So if we subtract 5 from both sides, we get x equals negative 5. I'm going to jot down the quadratic formula for you. There's your formula in case you need it. So negative b, we're going to have negative and then negative 5, because my b is negative as well, plus or minus the square root. It's b squared. So negative 5 squared minus 4. My a is 1 and my c is 25. All over 2a. So this becomes 5 plus or minus the square root of something. And remember what we did in Unit 5, you just type in these numbers. Do not include the square root. So just the numbers. And what number do you get under the square root? Negative 75 over 2. And that's not a perfect square. So I'm going to go here on the side. I know you don't have enough room for this, really. Sorry. This, we get the negative 1. What else goes into 75? What perfect square? 25 and 3. And this turns into 5i radical 3. So the ones with the cubes, just remember you have to do quadratic formula with those. Any questions? Let's do number 7. And then we'll probably stop there and do some more examples later. Number 7, it is set equal to 0. What type of factoring are we going to have to do? Do what? Difference of cubes, yes. So I'm going to try to write a little bit smaller to save my room because I know it's difference of cubes. I'm going to have to end up doing quadratic formula. So what is my A? X. What is B? 6. And if you look over here, 216, the cube root of that is 6. I kind of wrote those up there so you won't have to type as much in your calculator. What is A squared? X squared. AB, 6x. And B squared, 36. And when I write my factors, we get x minus 6 And then it's x squared plus 6x plus 36. So remember, your first sign matches your problem, then it switches. The last sign is always plus. Then we have to take each factor and set it equal to 0. So I'll do x minus 6 equals 0. So what is my x? 6. And then what do I have to do with my other factor? Quadratic formula. So this first step, all that I did was plug in my a, b, and c. And I'm going to get my number under the square root. And when you type these numbers in, you should get negative 108. And that breaks down. The negative 1 comes down. And then 36 times 3 is 108. Most of the time, the perfect square that you get down here is this number. Usually. Unless you have an A. So this is I, this is 6, this is still square root of 3. So negative 6 plus or minus 6i square root of 3 over 2. Is there anything else I can do to simplify? These three numbers right here are all divisible by 2. So if we divide all of those by 2, you don't have to worry about what's under the square root. Only the outside numbers, we get negative 3 plus or minus 3i radical 3. Ugh. I know, it's a lot. We're going to stop here for today.